Yo, this is Mr. O. Hello, this is Mr. O, and today we're going to learn about similar figures. How is similar different from congruent? Congruent figures are congruent to say triangle. They're perfectly the same. The corresponding parts of every angle, the size has to be perfectly the same, congruent. But when we talk about similar, they don't have to be perfectly the same. So let's go ahead now. Polygons with the same shape but different size. Okay, that's how you look at the similar polygons. Polygons that are similar if their corresponding angles are congruent. Okay, that's congruent. But their corresponding sides are proportional. Sorry. The ratio of a corresponding side is the scale factor. If polygons are similar, then the ratios are proportional. We say they're equal. Let's go with the scale factor here. How to identify scale factor? The order matters. Remember that, guys. What is the scale factor of triangle ABC to DF? So what you're going to do is you have to pick one side. Let's say I pick AB, the first two letters. AB are the first two letters here. So what will be the first two letters here? DE. So the partner of AB here is DE. So therefore, for me to know the scale factor, since ABC have mentioned first, so 8 to 12. What's 8 divided by 12? What's the lowest term of 8 to 12? Both of them are divided by 4. So this will be 2 over 3. That's a scale factor. It is important that you pick the corresponding parts of the other figure. Okay? What is scale factor of DF? So this time I start with DEF, which is right here. Let's say I pick 21, which is DF. The first and the third letter. So 21. What's the first and the third letter here? AC. AC here is 14. What's 21 is to 14? Or 21 by 14? Both of them are divided by 7. So this would be 3 halves. What is the ratio of the perimeter? Let's add them all. 8 plus 10 plus 14. That will give you 24 plus 8. That will give us 32. This will give us 12 plus 15, that is 27 plus 21, 48. What is 32? No, the other way around. What is 48 over 32? Why the other way around? The DEF was mentioned first before the ABC. And both of them are divisible by 2. This will be 24 over 16. They're still divisible by 2, so 12 over 8. This is still divisible by 2, 6 over 4. Still divisible by 2, 3 halves. If you notice, the ratio of the perimeter is the same as the scale factor. So a validity similarity statement must match the corresponding angles and side. Write a similarity statement of the triangle above. So I can say triangle ABC is similar. That's a notation for similar. DEF. Kaboom. Okay, let's apply this one now. List all the congruent angles and write a proportional that relates to corresponding sides. So for the angles, again, I know that J and P are congruent. Angle J and P are congruent. Angle K is congruent to angle M, and angle L is congruent to angle N. The sides that are proportional here, I know that JK is proportional to, say, PM here is equal to JL is proportional to PM, and KL will be proportional to MN. Okay, again, the order matters. It's easier to look at it based on the statement, or you can do it in the figure. Okay, alrighty, move on. So let's see if we have this figure here. Then I can just cross out. So let's apply the similarity polygons in finding the x. If the figure below are similar, so these two figures here are similar, with a scale factor of 2 is to 3, find the value of x. Since we know the scale factor is 2 to 3, or 2 over 3, therefore, that will be equal to 42 over x. We try to multiply it. 2 times x is going to be 2x. 3 times 42 will be 126. See, 3 times 42 is 126. Then divided by 2, that gives us x equal to 63. So therefore, the value of x here is 63. And you would agree with me that if you simplify 42 and 63, the scale factor there will be 2 is to 3. Okay? If triangle ABC is similar to triangle DF, find the value of x here. So we know that AB is here, which is x. That's what I'm looking for. AB matches with DE. Where's DE? DE is 25, so I'm going to write here 25 here. And then I need to find a proportional side that has all the values known. And I see here BC. BC are the two last letters there. So that's 28 over BC matches EF. EF is right here over 20. I can reduce the 28 over 20 to both of them are divisible by 4. This will be 7 over 5. So my equation now is x over 25 is equal to 7 over 5. Now I can apply the cross product property by multiplying x by 5. That gives you 5x. 25 times 7, that will give me 25 times 7 is 175 divided by 5. And x there is equal to 35. Boom. Very easy, right? If triangle DF is similar to HJG, find the values of x and y. So again, I will refer to what is missing. I'm missing x, GH, G and H. Those are the first and the third letter. So the partner should be DF. So I'm going to start with x over DF. First DF. DF is 12. Is equal to, I'm not going to write the y right now because I cannot have two unknown in the same equation. So I'm going to use JH. JH is 15. JH are the first two letters. So I'm going to use DE. DE is 9. So from here, I can apply the cross product property. I can simplify 15 over 9, but I'm just going to keep going here. 9 times x, 9x, 12 times 15 is 180. So divide by 9, so therefore x equal to 20. And I know I'm looking for y. Y is GJ. The part of GJ, the last two letters, is EF. So that will be over 14. And I'm going to use again 15 over 9. And I'm going to cross multiply. 15 times 14 and 9y equals 14 times 15 is 210. Divide them both by 9. It's going to be a fraction. 23.3 repeating. And that's how you